Hello my class 9 students. Want to continue working for full marks in ICSE Class 9 Physics paper? Well, this is the same sample paper number 2. I have already uploaded section A and now we are coming to section B. Now as you know, this is an 80 mark paper, out of which section B will be for 40 marks, just like section A. Now section B will have 5 questions, out of which we have to solve any 4. So let us look at question number 5 onwards. Here in section B, first one says define global warming, state its effect in agriculture, state 2 technological ways to minimize the impact of global warming. Now these are all learning topics, so you have to learn these by heart, prepare these questions. Let us see how we write them. So we've written section B, this is question 5A, global warming. We write the definition, you'll find it in any of your textbooks. It is the increase in average effective temperature near the Earth's surface due to increase in the amount of greenhouse gases in its atmosphere. The second one talked about the effect in agriculture. So the global warming has changed the blooming seasons of various plants. So the fruiting will be at different time intervals. B, it has changed the regional climate and that has affected the local plants. So that of course is going to impact the agriculture. Third subpart says state 2 technological ways to minimize global warming. And the 2 technological ways are, number 1, we use the renewable sources of energy for generation of electricity where the power plants are using fossil fuels. So it is fossil fuels against the renewable sources of energy. Second one, the transportation of the vehicles must be switched to battery operated vehicles from the internal combustion engine. And the charging of this battery can be done by electricity generated by the renewable sources. Question 5b, draw a graph showing variation of volume of water when heated from 0 degrees to 12 degrees. Now when you heat from 0 to 4, it is going to contract and then it's going to expand. So here is the graph for variation of volume of water when heated from 0 degrees to 12 degrees C. So we have x-axis in which we have shown temperature in degrees C, and on y-axis we have shown volume of 1 gram of water in centimeter cube. Now remember, at 4 degrees C the volume is 1 centimeter cube. So remember that as you heat it from 0 to 4, the volume is going to decrease and then after 4 it is going to increase. So we started with 0 degrees C and we have to end at 12. So make sure that this point over here, this point is exactly above this 12, and make sure that you are drawing this open curve, and that is how we draw the graph. Question number 5C, convert 65 degrees Fahrenheit to degrees C and 357 Kelvin to degrees C. Now this is part of our chemistry syllabus also, so you should be knowing about it. This however is the part of our 8th standard syllabus. Nevertheless, we know how to answer this. So question 5C, convert 65 degrees Fahrenheit to degrees C, and this is the formula. We write the temperature in degree Fahrenheit minus 32 and multiply it by the multiplication factor 5 upon 9. So 65 minus 32 gives us 53 into 5 upon 9. So we will have 3 3s and 3 11s. So we have 11 5s 55 upon 3 degrees C, and we'll have 3 1s, 3 8s, 24 remain 1. 1/3 means 0.33 degrees C, and that is our answer. For 357 Kelvin into degree C, remember from degree C if we have to convert to Kelvin, you have to add 273. So for temperature in degree C, we will subtract 273. So that gives us 84 degrees C, and that is our answer. So we finished with question number 5. Question number 6A. A metal bob tied to a string is hung from a rigid support. Draw and label the forces acting. Let's see how we draw that. So we show the rigid surface like this. Make sure to show these slanting lines. Then we show the string over here, and then we have the center of gravity. Through the center of gravity, the weight acts vertically downwards, and we show it as mg. This is the bob. 6b, give reason why a passenger falls down when he jumps out of a moving bus. Let's write the answer. So we written the answer. The passenger falls down when he jumps out of a moving bus, as the motion of the bus is given to his whole body while he is on the bus. As he jumps from the bus, his feet touch the ground, but his upper part of the body continues to be in the state of motion due to inertia of motion. However, his feet come to rest, and so he falls forward. Question 6c. How does the force of attraction between two bodies change if the distance between them is increased 4 times? Now, the force of attraction is not a contact force, it is the force acting from a distance. So remember, it is inversely proportional to the distance of separation. So here, let us see how we write the solution. We will call this as case 1 and case 2, where we'll have initial distance, let us say it is d, and your d2 has become 4 times d because distance of separation has been increased by 4 times. Okay, the force at a distance is inversely proportional to the distance squared. So we will have F1 upon F2 will be equal to d2 square upon d1 square, because it is inversely proportional. So if we substitute, your d2 is going to be 4d, the square of it, and divided by d1 is just d. So that will give us 16d square upon d square, which gets cancelled. So F1 upon F2 has become like this. So when you cross multiply, you will have F1 is equal to 16 F2, and therefore we will have F2 will become F1 upon 16. And so we will say, therefore the force becomes 1/16 of the original. And that is our answer. 6d. The weight of the body on earth is 150 Newton. Find the mass of the body. Now this one is a very simple question. Question 6d. We know that the weight of the body is 150 Newton, and weight means it is mg, and the value of g is 10 meter per second square. Therefore, we will have weight equal to mg, which is equal to 150 Newton. Therefore, m multiplied by 10 meter per second square, that's the value of g, is equal to 150 Newton. And therefore, mass is equal to 150 Newton divided by 10 meter per second square. And that will give us 15 kg, and that is the mass which we had to find, and that's our answer. Let us look at 6e. Car acquires the velocity of 72 kilometers per hour in 10 seconds starting from rest. Calculate the average velocity, its acceleration, and the distance covered during this time. So let us write our question 6e. It acquires 72 kmph, that means it is final velocity. It is 72 kmph, which will have to convert into meter per second. So we multiplied by 5 upon 18. So 18 goes 4 times, and that gives us 20 meter per second. The initial velocity is 0 meter per second. They are telling us that the time taken is 10 seconds. The average velocity is initial velocity plus final velocity upon 2. So that will give us initial velocity is 0, final velocity is 20 upon 2. So that gives us 10 meter per second. This is the average velocity. And that is our answer 1. Now we look at the second part, the acceleration. Now acceleration is v minus u upon t. Our final velocity is 20, initial velocity was 0 and the time taken is 10. So you will have 20 upon 10, that is 2 meter per second square. That becomes our answer 2. We come to the third part, distance covered during this time. Now distance will be s equal to ut plus half at square. This formula will be using to get the distance. So initial velocity is 0, 0 into whatever time will be 0, plus half, acceleration is 2 and the time is 10 times 10. So we'll have 2 and 2 getting cancelled and we will have 10 into 10, which is 100 meter, and that is our answer 3. So we have finished with question 6a. Question number 7a, observe the diagram and answer the following. Now what apparatus is this? Don't you know that this is Hope's apparatus? We know that this is filled with water, and this one first is your thermometer T1, which is denoted by A, and this is T2, which is denoted by B. Which of the thermometers will show the change in temperature first and why? Now when we are filling this tray over here with ice and salt, the temperature of the middle region is going to fall. So the water over here is going to show fall in temperature, and the water in this region is going to become cool. When it becomes cool, it will become denser and it will settle down here. Whereas the upper part is still warmer compared to this temperature. So because it has got less density, it will be staying on top itself. But this water becoming denser comes down here. So 7a, the thermometer B shows the fall in temperature first. And what I explained, the same thing we are writing. The water in the middle part cools, its density increases, so it settles down, and therefore B shows the fall in temperature first. State the composition of the freezing material and its purpose. So we will say freezing material is made of ice and salt to provide sub-zero temperature to the water in the middle part of the apparatus. State the final temperatures obtained by thermometers A and B. So we will have the third part. A will be showing 0 degrees C and B will be showing 4 degrees C. Draw the temperature time graph for thermometer A. Now thermometer A is going to show steady temperature and then slowly it is going to go up to 0 degrees C. So we drawn temperature time graph for A. This is the time graph, and time could be in seconds or minutes. This is your origin, this is your temperature axis, and this is the room temperature. Now initially the thermometer is going to show steady temperature, and then slowly it is going to drop the temperature not just to 4 degrees C, but also it is going to go up to 0 degrees C. So this is our temperature time graph for thermometer A. What conclusion can you draw from the above experiment? So our conclusion is that water exhibits anomalous expansion on cooling below 4 degrees C. Instead of contracting, it expands. It is densest at 4 degrees C. So that is our conclusion, and that finishes our question number 7. Question number 8a. A rear view mirror has a radius of curvature 3 meters. If the bus is located at 5 meters from the mirror, find the position, nature and the size of the image. So let us write our data. We have radius of curvature, and so therefore the focal length will be equal to half of it. The bus is located 5 meters from the mirror. So the object distance is 5 meters. And we have to find the position, nature and the size of the image. So the first thing we have to find is the image distance. Now remember, this is a convex mirror. So convex mirror focal length is positive and the object is in front of the mirror, so the object is going to be negative. Let us use our formula. 1 upon f is equal to 1 upon u plus 1 upon v. Reciprocal of f means it will be reciprocal of 3 upon 2. So we will write 2 upon 3 is equal to 1 upon minus 5 meter plus 1 upon v. So we will have 1 upon v equal to 2 upon 3, and this comes here. So it becomes plus 1 upon 5. That will give us 15 as the LCM, 3 5s, 5 2s, 10 plus 5 3, so it will be like so. So our 1 upon V is 13 upon 15. Therefore V is equal to 15 upon 13. So that will be 13 ones 13, remain 2. So 1.154 meter, and it is positive. So now they want the position, nature. So the image will be 1.154 meter behind the mirror. It's going to be a virtual behind the mirror. It's the virtual image. What is the nature? Image is virtual, and the size. Now for the size we have to show the magnification. So we finished up to the distance and the nature. Then we look at the size. For the size we think of magnification, which is minus v upon u. Okay, so minus, what is our value of v? It is 15 upon 13. And what is the value of our u? It is 5 meters, so it is minus 5. Correct? So that will give us minus minus getting cancelled, and 15 upon 13 multiplied by 1 upon 5. So 5 ones and 5 threes. So you will see that your I upon O is going to be 3 upon 13, which is less than 1. If the object is 13 centimeter, image will be 3 centimeter. So you will say therefore image is diminished. And how much will it be? Size of image is going to be 3/13 of size of the bus. Okay. Now we come to 8b. Derive the relation between the CGS and the SI unit of force. Now CGS unit of force is going to be dyne, and the SI unit of force is Newton. All of you know that, correct? Now we have to find the relation between the two. So you will have 1 Newton is equal to 1 kg into 1 meter per second square. You have to know this. So 1 kg means it will be 1000 grams into 100 centimeter per second square. So that gives us 10 to the power 5 dynes. But they are saying relation between CGS. So therefore we will say 1 dyne is equal to 1 upon 10 to the power 5 means 10 to the power minus 5 Newton. And this is the answer. We come to question 8b, second part. State 2 conditions needed for F equal to m into delta V upon delta T to hold true. Now what is the first condition? That the mass must remain constant, correct? This is the first condition, and the second condition will be that the velocity of the body should be very, very less than the speed of light. In other words, V should be very, very less than C. So that finishes our 8B. C. 8C. When will the upthrust acting on the body immersed in the liquid be maximum? Upthrust maximum. When will it be maximum? If it is completely immersed, the volume displaced by the liquid will be maximum, correct? Upthrust will be maximum when the body is completely immersed in the liquid. Why? Because it will have displaced the maximum volume of liquid. D. The slope of displacement time graph is positive. What does it indicate? So question 8D is talking about displacement time graph. Just draw a small graph like this and say this is displacement and this is time. Okay, and they say that the slope is positive. Now if the slope is positive, the graph will be like this. It cannot be this way. If the graph is like this, then it's going to give a negative slope. If this angle theta is acute, we'll have positive slope. So what does this indicate now, this graph? Isn't the displacement increasing with a time? Now displacement, your slope delta y upon delta x, correct? So that is going to be displacement, change in displacement with change in time. So that is going to be equal to displacement upon time. Now if it's a straight line graph and it is positive, that means we are having a uniform velocity. So what does it indicate? Therefore, the graph indicates uniform velocity. Now what is the meaning of uniform velocity? As it covers equal displacement in equal intervals of time. And that is our answer. Let us come to question number 9A. Density of steel is given this much. A cube of steel that is 0.1 meter each side is placed in the tank of water and weighed inside the water. Calculate the weight of the cube in air. Now we have been given the density of the cube is 9,000 kg per meter cube. The volume of the cube is going to be equal to 0.1 meter whole cube. So that will be 0.001 meter cube. There will be 3 places of decimal here. Now we know that density is mass upon volume. Therefore mass will be equal to density into volume. So our mass will be equal to density is 9,000 kg per meter cube multiplied by 0.001 meter cube. Now meter cube got cancelled and we have these 3 zeros will cancel with these 3 decimal places which are actually zeros in the denominator. So we will have 9 kg. And so if they want to find the weight of cube in air, so our first answer will be weight in air will be 9 kg multiplied by g, which will be 90 Newton. You could also write 9 kgf because it is 9 kg, the weight in air becomes 9 kgf. But I want to write the SI unit. The upthrust act. Now it is completely inside the water. So your upthrust is going to be equal to V rho G of the water. Now how much is the volume displaced by the water? The same as the volume of the cube. So it will be 1 upon 1000 meter cube multiplied by density of water is 1000 kg per meter cube multiplied by g. So we have all this getting cancelled and we will have 1 kg into gravitational acceleration. So that will be 10 meter per second square. That is equal to 10 Newton. So this is the upthrust, and that is our answer 2. This is your answer 1. What is the third part? The apparent weight of the body. The apparent weight of the body will be weight in air minus the upthrust. How much is the weight in air? 90 Newton. How much is the upthrust? 10 Newton. How much is the apparent weight? 80 Newton. Now, if you choose to write this in kgf, then it will come out to be 8 kgf. Okay? Question 9b. Name and define the SI unit of gravitational force. Now, gravitational force is a force, SI unit will be Newton. And state the relation with the CGS unit. So that will be your dyne. So we are going to say question 9b, SI unit of gravitational force is Newton. Remember to write it with small n. And the CGS unit is going to be the same as the unit, CGS unit of force. So that will be dyne. And then what is the relation? 1 Newton is equal to 10 to the power 5 dynes. We've already done this earlier, but we will just show the working because I can see that it is for 2 marks. Okay, so this derivation you already know. Name the mirror used as a reflector in solar cooker and why. Now, in a solar cooker, the rays of the sun have to be focused. The mirror used in the reflector of the solar cooker is going to be concave mirror, because we need to focus the rays of light on the food. We don't want them to be diverging rays. So the converging rays will be offered only by concave mirror. Draw the diagram to explain it. So for this, you can show just a diagram like this. You can show this. I'm just showing it freehand. So if the parallel rays of light are striking the concave mirror, if this is the principal focus, then the image will be formed at the focal plane. This is how we will show the rays. This is our principal axis. Then we show this as the concave mirror. Okay, and this is the incident ray. These are the reflected ray. And this is the image of the sun. And this is where we'll have to place our food in order to cook. Because not just the light radiations will get concentrated, but also heat radiations will get concentrated. Okay. Question 9d. How will the pressure acting on a body change when the force applied is halved and the areas also halved? So let us make the 2 columns, case 1 and case 2. The force applied is halved. So F1 is F and F2 is F upon 2. So we have the force is halved and the area is also halved. So area 1 is, let us say, A. Then area 2 is also halved. Now we know that pressure is thrust upon area. So that is F upon A. So we will have P1 is to P2 will be equal to F1 upon A1 is to F2 upon A2. F1 is F, area 1 is A, F2 is F upon 2 and A2 is A upon 2, but it's dividing, so it becomes 2 upon A. What happens over here? Can you see that? It is F upon A is to F upon A, which will be 1 is to 1. So how does the pressure of the body change? What we will say, therefore pressure remains the same. Okay, and that finishes the entire paper. Now in this paper, section B had not 6 questions, 5 questions. And out of these 5 questions, 4 questions had to be attempted. So I hope we have understood how we have to write the answers, how to think under the circumstances, and if your exam is coming closer, then Study well, practice well. All the best. Stay safe, stay healthy. Bye.